Welcome to the Sustainable Return on Investment Learning Module. In this module, you will learn how the Sustainable Return on Investment Framework, also referred to as SROI, has been applied to a military health system project, the methodology behind the framework, and about resources to assist in the implementation of the framework. This module will explain the purpose of using SROI on military health system, also referred to as MHS projects, provide an overview of the SROI framework, outline the key elements of SROI methodology, give examples of SROI results and outputs, discuss the SROI process including key milestones on a project, discuss the applicability of the framework for various MHS projects, examine an MHS SROI case study, and provide a review of the module and a list of available SROI resources. Section 1 of the Sustainable Return on Investment Training Module, Purpose. The SROI framework provides a full accounting of the financial, social, and environmental impacts of projects, providing a business case with which to select and document strategies utilized on MHS projects. It is scalable and can be implemented on a range of project types, including building construction and retrofits, base-wide planning, and program-level planning. SROI ensures that the most effective facility lifecycle management sustainability approaches are prioritized for the project by helping teams to optimize design strategies while minimizing negative social or environmental impacts. Later in this module, a more in-depth explanation of the SROI framework will be provided. The SROI framework can be implemented on MHS projects to assist with accomplishing the Department of Defense's Strategic Sustainability Performance Plan goals, also referred to as SSPP, supporting DoD's mission, engaging in fiscal stewardship by going beyond life cycle costs and taking a triple bottom line perspective using a process that is objective, transparent, and scalable, and helping to achieve world-class requirements. The DoD's SSPP provides goals, objectives, and performance-based sub-goals and guidance for compliance with federal sustainability requirements and for ensuring the mission. The plan states, DoD embraces sustainability as a critical enabler in the performance of our mission, recognizing that it must plan for and act in a sustainable manner now in order to build an enduring future. The DoD mission is incorporated into the SSPP and aligns closely with overarching federal sustainability goals to form the following priorities for the department: energy and reduced reliance on fossil fuels, chemicals of environmental concern, water resources management, and maintaining readiness in the face of climate change. A life cycle approach is integrated into the DoD's SSPP. It calls for the use of a bottom-up approach for budgeting and execution of its objectives. The plan states, at the policy level, the department is preparing a DoD instruction on sustainability, specifying that it is DoD policy to ensure that the department's commitment to sustainability is reflected in all investment decisions by considering the costs and benefits of factors impacting sustainability. The SSPP's bottom-up approach is in accord with Executive Order 13514, which directs agencies to prioritize actions based on a full accounting of both economic and social benefits and costs. In addition, agencies' efforts and outcomes in implementing this accounting process are required to be transparent. SROI provides a full accounting of both economic and social benefits and costs, which makes it a preferred methodology to address SSPP priorities on projects using a triple bottom line approach. As shown on the screen, traditional lifecycle cost analysis, also referred to as LCC, includes cash benefits and cash costs. The SROI framework includes LCC but adds non-cash impacts, Non-cash impacts include both non-cash benefits and non-cash costs and are quantified as part of the SROI process. This means that within the SROI framework, the entire scope of potential benefits and costs related to sustainable design are being considered. One of the biggest benefits of SROI is that it replaces emotional discussions with objective and structured discussions and decisions, which are quantifiable, transparent, and scalable. The SROI framework brings value to project stakeholders, internal and external, because it can simultaneously address the world-class checklist, executive orders, and other federal mandates into a common denominator, dollars. This allows for a project's sustainable design alternatives to be evaluated objectively and acknowledges the reality of risk by using probability analysis to address the variability of real-world outcomes. SROI has been used successfully for a variety of projects across North America, including projects for the Army, Navy and Air Force, the Department of Energy, and local governments ranging from the City of Boston to the City and County of Honolulu. In summary, implementing the SROI framework on MHS projects assists with accomplishing DoD's SSPP goals, supporting DoD's mission, including the 4 priorities, engaging in fiscal stewardship by going beyond LCC and taking a triple bottom line perspective using a process that is objective, transparent, and scalable, and helping to achieve world-class requirements. Section 2 of the Sustainable Return on Investment Training Module, Overview. Traditional business case models, such as life cycle cost analysis and financial analysis, often fall short from a triple bottom line perspective. Their primary shortcomings are that they only consider cash impacts. They do not monetize or value environmental and social impacts. They do not account for uncertainty in the values of the inputs. And finally, they lack transparency. The SROI process is intended to overcome all of these shortcomings. So what exactly is the SROI framework? It is best practice in cost-benefit analysis and financial analysis over a project's entire life cycle, augmented by accounting for uncertainty using state-of-the-art risk analysis techniques, engaging stakeholders directly to generate consensus and transparency. SROI adds to traditional financial analysis the monetized value of non-cash benefits and externalities. You can see on the left that a traditional business case provides a financial return on investment, or FROI, based strictly on the cash impacts of a project, whereas the SROI analysis adds non-cash impacts internal to a particular organization as well as the external impacts that affect society as a whole, for example, greenhouse gases and air pollutants. This provides project managers with a full accounting of the benefits and costs of various project strategies from a triple bottom line perspective. This diagram graphically depicts the SROI framework. Some of the internal cost and benefits that can be added to the business case for an MHS project include patient and employee health and safety, resiliency, as in the ability for an installation to operate off the grid, and the elements related to world-class principles. In addition, the external cost and benefits to society can include greenhouse gases and other air pollutants, water quality impacts, as well as other items like odor and noise. The S-curve diagram is a representation of the results obtained through an SROI analysis of costs and benefits, such as those illustrated on the previous slide. The split between what is internal to an organization, the blue and brown S-curves, and external, the green S-curve, depends on the specific project. For example, health and safety impacts would be internal to the MHS, whereas they would be externalities for most private sector organizations. Each S-curve shows the complete probability distribution for its respective output metric, ranging from the worst case, just above 0% probability, to the best case scenario, or the 100th percentile. The gap between the FROI curve and the SROI curve represents the monetized value of all the non-cash impacts that are usually discussed only qualitatively in a typical decision-making process. What this means is that the true value of a sustainable investment is revealed in a transparent and objective fashion. This flow diagram further illustrates in graphical form how SROI business cases differ from traditional LCC or FROI. The cash benefits and cash costs remain essentially the same as in the traditional analysis. The difference is that SROI includes non-cash impacts. As will be detailed later in the module, these benefits and costs are identified and quantified during the SROI process. The resulting output metrics reveal the full value of the project. FROI and SROI provide common economic output decision metrics, which include net present value, the sum of the present value of future cash flows less the present value of the project's costs. Return on investment, the ratio of the net value of an investment relative to the cost of the investment. Discounted payback period, the period of time required for the return on an investment to recover the sum of the original investment on a discounted cash flow basis. Internal rate of return, the discount rate at which the net present value of a project would be zero. Benefit to cost ratio, the ratio of the benefits of a project relative to its costs, with both expressed in present value monetary terms. Traditional FROI outputs reflect the typical financial business case, and SROI outputs reflect the business case from society's perspective. When SROI is implemented, both sets of outputs are provided to the project team. This enables the team to make decisions based on transparent and comparable outputs. These two sets of metrics can be used as part of a successful screening process when determining which alternative or set of alternatives is optimal. The first stage of the screening process is to determine which options are technically feasible. The second stage is to identify alternatives that are affordable. The third stage is to determine which of the remaining options are acceptable to the various stakeholders. The fourth and final stage in the process is to perform a complete SROI analysis on the final list of reasonable alternatives. This will determine the optimal solution from society's perspective and the overall impact to society as a whole. Section 3 of the Sustainable Return on Investment Training Module, Methodology. Thus far, an overview of the Sustainable Return on Investment framework has been discussed. Next, the four-step methodology for completing an SROI analysis will be described. The first step in the SROI process is to use structure and logic diagrams to illustrate what is calculated in the Excel-based models. Here is an example of a structure and logic diagram from the Denver Metro Wastewater Reclamation District SROI project, which illustrates how the model calculates the social value of the greenhouse gas and criteria air contaminant impacts of various water treatment plant alternatives. The diagram maps out and provides information to allow the SROI model to capture the non-cash costs of the impacts of greenhouse gases and criteria air contaminants that would be generated from the source power generation plant, Colorado Electric, as a result of implementing the project. Part of the SROI process is to depict the variables and cause-effect relationships to be captured in the model with diagrams like this one. Step 2 is the most important step in the process. This is where a range of monetary values is added to each input. The primary source of data is meta-analysis of the best available third-party scientific and economic research and data. This information often comes from well-known federal sources like the Department of Transportation or the Environmental Protection Agency. This information is gathered both before and during the Risk Analysis Process Workshop, Step 3 in the methodology. Additional sources include financial and insurance markets like the European Carbon Exchange, contingent valuation, also known as willingness to pay surveys, based on third-party research, or as a last resort, Bayesian analysis or expert opinion to form a range of values for a given input, all of which are incorporated into the analysis. Part of quantifying inputs is introducing risk into the process, as shown in this diagram. It shows the probability distribution used in a recent study to quantify the social value of an incremental ton of carbon dioxide. These values were selected by reviewing over 200 published social values for CO2 that have been produced by economists in the last decade. The curve is defined by 3 key points of reference: the median, minimum, and maximum values which map out the curve. In this case, the median or middle value of the dataset was sourced from the IWG-SCC, a committee of large federal government departments. The minimum value is derived from the 2008 William Nordhaus book, A Question of Balance, and the maximum value is based on Nicholas Stern's 2006 The Economics of Climate Change. The mean or average of the dataset and standard deviation, which measures how spread out the dataset is also calculated. When the model performs the risk analysis by running numerous iterations of possible results, it will sample the different financial values of CO2 from the entire range of possible values under the curve. This means that the model will consider all possible values for each input when it runs the SROI analysis, and will produce a suite of results. This allows the project team to consider the impact of data variability on the financial output results and factor that variability into its decision process. The third step of the process is the Risk Analysis Process Session, also known as the RAP session, which is the key to transparency and consensus building. Key stakeholders gather for anywhere from a half-day to multi-day sessions to review and refine the structure and logic models and the probability distributions for every input in the model, ensuring that everyone understands and has an opportunity to comment on the workings of the model. The risk analysis element of the SROI process allows most participants to feel that their personal viewpoint has been incorporated into the model. The fourth step is to run the model and calculate results using Monte Carlo simulation to produce the complete range of possible values. The SROI models are built in Excel and use different analysis tools, such as the at-risk add-on as the risk analysis software. The model runs produce a complete range of possible values for each of the strategies being analyzed. This is illustrated in the curve seen for each of the 4 individual strategies analyzed in the example above. The analysis also takes into account jointly determined probabilities for combinations of those strategies, producing a combined set of output metrics. All result outputs are also Excel-based and can easily be incorporated into documents and presentations. Section 4 of the Sustainable Return on Investment training module, Example Results and Outputs. We've just covered the methodology of the SROI framework. Now we move into examples of actual SROI analysis outputs to help illustrate how your MHS project could benefit from an SROI analysis. SROI was performed on a DoD MHS project, the new Fort Belvoir Community Hospital in Virginia, to identify the net benefits of building a LEED-Silver hospital versus building an industry standard design hospital. The SROI analysis studied the business case behind investing in the sustainable energy and water initiatives that contributed to LEED certification. We will examine the financial impacts of incorporating design strategies that reduce energy and water consumption at the hospital. If you look at the 2 rightmost slices of the pie chart, you can see the two benefits that were incorporated into the traditional financial business case: energy bill savings and water bill savings. These benefits from the FROI standpoint provide a cash return on investment of 15.9% to the military. When the non-cash value of reducing greenhouse gases, criteria air contaminants, and water used are added to the business case, as shown on the left side of the pie chart, the results improve to 39.3% return on investment from society's perspective. Here's another example of SROI results. This time looking at the total discounted present values over the 45-year life of the design, construction, and operation for an on-site wastewater treatment plant at the new Fort Bliss Hospital replacement in Texas. This treatment plant would be the first of its kind for a U.S. military hospital. The SROI analysis compared the triple bottom line financial impacts of constructing an on-site wastewater treatment plant to constructing miles of new sewer line to connect into the existing El Paso municipal system. This table demonstrates that even though the treatment plant would not be life cycle cost effective from a cash perspective, it would provide net public benefits from an SROI perspective, as seen in the positive net present value result. Using a traditional FROI analysis, the project showed a negative return on investment, high discounted payback period, and low benefit-to-cost ratio. However, when the social and environmental benefits were factored in for building an on-site wastewater treatment plant, the financial case for implementing the strategy significantly strengthened. The SROI analysis showed the on-site treatment plant would also provide net public benefits. This table identifies how the net present value figures on the previous table were derived for the on-site wastewater treatment plant. The FROI results only include potable water cost savings, incremental O&M costs, and incremental capital costs, whereas the SROI results include those costs plus the societal impacts by accounting for potable water savings, social benefits, criteria air contaminant social cost, greenhouse gas social cost, and nuclear energy social cost. The addition of the societal impacts obtained by constructing the plant versus constructing an additional sewer line results in a positive net present value for the proposed project. SROI results can be presented in a variety of ways. The most interesting format for the presentation of SROI results is the Sustainability S-curve diagram, which is depicted here. It provides the complete FROI and SROI risk-adjusted picture. This diagram delivers the complete triple bottom line results in one image and has been very well received by project owners using SROI. The y-axis on the left represents the likelihood of a specific outcome, while the x-axis at the bottom, in this case, depicts the return on investment metric that can also represent the net present values, internal rates of return, or the financial metric of interest. To help explain what this diagram means, here are a few things to look for, identified by letters on the diagram. A compares the difference of the x-axis financial metric between the FROI and SROI analysis over the full range of outcome probabilities or risk profile. In this example, the sustainable return on investment is more than double the traditional return on investment over most of the risk profile. B shows the effect of an SROI analysis on the financial metric versus the FROI analysis at a specific probability. In this case, the 50% risk probability or mean is the decision point. The percentage return on investment realized by evaluating non-cash benefits, both internal to the organization, such as improvements in employee health and productivity, and external to the organization, such as environmental benefits to the larger community, increased from 12% to 27%. C assesses the statistical likelihood that the result will fall within an 80% confidence interval. In this example, sustainable return on investment ranges from 15% to 34% within that confidence interval, with a mean SROI of 27%. This allows the project team to assess the potential variability of the results. Here is an example S-curve from the SROI analysis of Johns Hopkins University's Campus Sustainability Initiative. As you can see, if a traditional business case analysis had been conducted, the initiative would have shown an 11% return on investment. However, because this was an SROI analysis, the results show the SROI return on investment for society is a much more robust 43%. The difference between these two figures is the result of monetizing all of the positive effects of the initiative, such as improved health, reduced pollution, and water savings. This is a compelling example of how an SROI analysis can produce a strong case for or against the evaluated initiatives by identifying the full benefits of a sustainable investment. It also demonstrates that the framework is scalable because this analysis examined an overall campus sustainability program. It is also important to note that the SROI process does not greenwash investments that are not sustainable. For example, in this project, it was believed that thermally drying the biosolids produced at the wastewater treatment plant was a better environmental option than using them for fertilizer. Therefore, this option remained under consideration even though from an FROI standpoint it showed a negative net present value of $112 million. Including internal non-cash impacts reduced this slightly to a negative $111 million. But a full SROI analysis that monetized the externalities, in this case the social costs of the incremental energy used for the thermal drying process, pushed the net present value further negative to $128 million. This is demonstrated by the fact that the green SROI curve is to the left of the blue FROI curve. Monetizing and assigning risks to the non-cash and external impacts allowed for a full cost accounting of the business case and brought objectivity and transparency to the decision-making process. The SROI framework also allows the project team to see the financial impacts of implementing a strategy across the suite of probabilities, or in other words, to evaluate the financial risk of implementing the strategy being analyzed. In the case of the wastewater treatment plant biosolids strategy shown on the left, the model results show a consistent negative impact of approximately $17 million throughout the suite of probabilities. Therefore, the decision process would not be impacted by risk in this case. However, although the SROI model results for campus sustainability at Johns Hopkins on the right show a positive increase to net present value across the suite of results, there is variability in how much an SROI NPV increases over the NPV of a traditional FROI analysis. At the mean, or 50% risk level, a 32% positive differential is expected. This increases to 37% at the high end of the risk profile, 90%, but decreases to 28% at the low end of the risk profile, 10%. There is at least a 90% chance that total benefits will exceed total cost, but the amount of the exceedance varies across the risk profile. Monetizing the impacts across a full suite of probabilities by applying the SROI framework allows the project team not only to determine if a strategy is financially beneficial from a triple bottom line perspective, but also shows how much risk is involved with implementing the decision, allowing the team to make fully informed, objective design decisions. In summary, the SROI framework includes the following processes: developing structure and logic diagrams to illustrate the inputs and relationships for each strategy being analyzed. Quantifying input data assumptions to facilitate objective discussions and monetized decisions. Conducting a risk analysis process session to refine inputs, assign risk, and build team consensus. And quantifying benefits by running the SROI model for all strategies across a suite of probabilities. The model outputs, presented in a series of tables and S-curve diagrams, will allow informed, transparent, and scalable decisions to be made on MHS projects. Section 5 of the Sustainable Return on Investment Training Module, Process and Key Milestones. This portion of the module will illustrate when SROI should be implemented on MHS projects. SROI is not a single event, but rather a process incorporated through multiple phases of a project. Typical project phases are pre-design, S1, S2, S4, procurement, construction, and operations. SROI can be implemented on both design-bid-build projects and design-build projects to help teams to facilitate effective design and construction decisions. This diagram shows the traditional design process of a project in blue. The red dot represents a point in time when sustainability is typically implemented into the traditional design process. The gray curve represents the possible higher cost impacts the later sustainability is introduced into the project decisions. Integrating sustainable design and the SROI framework into the design process during pre-design, represented here in green, informs decisions early, increasing the team's ability to positively impact project costs. SROI is suitable regardless of the project delivery method selected. In design-build, it would most effectively be used in the bridging documents or to ensure solutions proposed in a design-build project are effective over the facility's lifecycle. SROI has been widely used in both design-bid-build, illustrated above, and design-build environments to deliver the best value at a competitive cost. The SROI methodology is synced to key milestones in the design process, and the process can be tailored to best meet a project's needs and decision points. This table provides an illustration of the application of SROI during key milestones on a particular design-bid-build government project. In pre-design, the design team develops strategies to be evaluated. During S1, the project team meets for a risk analysis process workshop. It is conducted concurrently with other project meetings and is not a standalone event. Following the workshop, the final structure and logic diagrams are created and the analysis is conducted. The results are provided in a report for the government to review. After the government reviews the report and provides acceptance, the design team incorporates the decisions into the S1 schematic design development. The SROI process remains active past S1. Updates and reviews are conducted as necessary as design decision milestones are approached to calculate the final outputs. Section 6 of the Sustainable Return on Investment Training Module, Applicability. The SROI process is completely scalable from small projects to large. It can be implemented on a single initiative, facility, base, or program. For example, the SROI process was used during the design of the Fort Bliss Hospital replacement to evaluate deep geothermal energy, at the Fort Belvoir Community Hospital to evaluate the energy and water savings impacts, at Johns Hopkins University to evaluate the energy and water usage of 4 campus buildings and the university's waste reduction program, and at the Marine Corps Air Station in Japan to provide a comprehensive framework for the assessment of sustainability planning, execution, and management at the base level. SROI is a scalable framework which can be applied to projects to address the SSPP, the World Class Checklist, executive orders, and other federal mandates. The results of the SROI framework are provided in dollars, which helps to replace emotional discussions with objective and structured discussions and decisions, which are quantifiable and transparent to all parties, internal and external, to the process. It can be applied to projects of varying sizes, including large-scale projects such as the Fort Bliss Hospital replacement. The next section of this module will explain how the SROI framework has been implemented on the Fort Bliss Hospital replacement. Section 7 of the Sustainable Return on Investment training module. Case study. The Fort Bliss Hospital replacement project includes the design of a hospital, clinics, administration building, clinical investigation building, and central utility plant in El Paso, Texas. This case study will cover the pre-design through S2 phases of the project, explaining how the project team used the SROI framework to make informed decisions related to sustainable design, evidence-based design, and world-class requirements. During pre-design, the team developed 75 strategies related to sustainable design, evidence-based design, and world-class design. These were then narrowed down to 15 strategies based on which strategies inform S1 concept design level decisions, which strategies need a triple bottom line study, and what decisions need to be made prior to S2 schematic design. These selected strategies became the SROI study list for the S1 SROI analysis. The 15 remaining strategies are listed on the right and correspond with a building or buildings they impact on the Fort Bliss site plan shown on the left. A campus approach was taken for implementation of the SROI framework in order to evaluate the triple bottom line for the entire project. The process looked at a number of different energy strategies, ranging from ways to generate the energy, including cogeneration, geothermal direct heating, and solar photovoltaics, to ways to recover exhaust energy. The economics were also examined from an SROI perspective for water savings, on-site recycling, and various indoor air quality strategies. An SROI risk analysis process workshop was conducted during pre-design to analyze these 15 design strategies, allowing the decision point shown on the graph to reflect a triple bottom line approach and optimizing the window of opportunity to positively impact project costs. The 15 targeted initiatives were thoroughly studied, evaluating their triple bottom line impacts. This timeline displays the key milestones of the SROI process aligned with the key milestones of the project schedule. At the end of the S1 design phase, the SROI results were provided to the client in a draft report. The government's comments were then incorporated into a final S1 report, which was submitted at the beginning of the S2 phase and used as a decision-making tool as design work continued. As design progressed into the 60 and 80% S2 phase, the project team was able to provide more detailed inputs and the economic models were recalculated. At 100% S2, an SROI review conference was held with all key stakeholders. At S4, final results were provided to the government, summarizing the design decisions and SROI output. Now we will walk through the process of applying the SROI framework to one of the 15 strategies evaluated during the S1 phase. This slide shows the structure and logic diagram developed for using solar photovoltaics as a source of clean power generation for the hospital. The diagram illustrates the inputs for the calculations underlying the analysis. The primary benefits are the reduced electricity costs and the corresponding decrease in greenhouse gas and criteria air contaminant production. The strategy was evaluated over a 40-year lifespan. Discount rates were applied, and inflation was accounted for within the model. The SROI model was run for this strategy using quantified data inputs for these cash and non-cash benefits across a full risk profile. The results at S1 showed a negative net present value for both the FROI and SROI analysis. At the 50% or mean probability, a negative net present value of $3.2 million resulted, primarily due to the initial high cost of the system installation and the cost of increased water consumption for maintenance cleanings, which were expected to be needed more frequently than for a typical system due to the occurrence of dust storms in El Paso. The SROI analysis, incorporating the non-cash benefits and externalities, showed a positive social benefit for this renewable power generation strategy. However, this benefit was not enough to offset the internal costs, as seen in the S-curve diagram. The diagram shows the net present value improved by $500,000, but still resulted in a negative $2.7 million NPV. This strategy did not move past the S1 design phase. Included with the SROI report and updates to the government was the Capital Allocation Dashboard. The dashboard assists decision-makers by graphically summarizing the results of the SROI evaluation and organizing the strategies into 3 categories. Green represents strategies moving forward to the S2 design. These strategies show a positive return on investment. Red represents strategies that either did not fit into the project's allocation or showed negative results from either an SROI or FROI analysis. And yellow represents strategies that needed further review as the design progressed into S2 and more information became available. The Capital Allocation Dashboard helped the project team to consolidate specific strategies into comprehensive paths. As shown on the left side of the table, the 15 strategies are broken into the following separate groupings: energy bundles, water, waste, and evidence-based design. The analysis indicates either green, red, or yellow, and the status column notes which strategies will be incorporated into future phases of design, or if more analysis is required to make that determination, which is indicated by a report at S4 notation. The full analysis, including dollar amounts, can be found in the S1 SROI report prepared for the Fort Bliss Hospital replacement on the MHS World Class Facilities website. Section 8 of the Sustainable Return on Investment training module. Review and resources. In summary, implementing the SROI framework on MHS projects assists with accomplishing DoD's SSPP goals, supporting DoD's mission, including the 4 priorities, engaging in fiscal stewardship by going beyond LCC and taking a triple bottom line perspective using a process that is objective, transparent, and scalable, and helping to achieve world-class requirements. The references mentioned in this training can be found on the MHS World Class website.